Before we start discussing in a bit more depth the different troubleshooting challenges that we could have with NTP, let's remind ourselves how we set it up. We've got work to do on our NTP server as well as our client. Now let's assume that we've gone into our NTP server and we're going to source time from that internal clock in that router. If we are doing that, we're going to use the NTP master command, and we're here giving a stratum value of a 4. Now, if we did not trust our internal clock, if I were wanting to point to some internet-based time source, even though this router was going to be the time source for my network, I would not need to say NTP master. Even if it was going to be the authoritative time source on my network, I would simply give a command like this. I would say NTP server and point to that source. The only time we need to say NTP master is when we're using our internal clock as the time source, but let's see how we set it up like this. We're saying that we're the NTP master, our clock is the authority, and we have a stratum value, a believability of 4. If somebody learns from me, then they're going to have a stratum value of 5. It's going to increment by 1, remember. And we can optionally configure authentication for NTP. If we do, we need to specify an NTP authentication key. And right now we're using the MD5 hashing algorithm. We're going to pass the MD5 hash across the network. And I'm using a variant on the word Cisco as my key. And I'm going to say the key that I'm trusting is key number 1. And then I want to say I want to do authentication. We have a very similar configuration on our client. I'm pointing to the server's IP address that we just configured. I need to have matching authentication key, trusted key, and authentication and NTP authenticate commands. One exception, this number is locally significant. It just needs to match up within that router's configuration. Let's go out and set this up, and let's make sure it works, and maybe give a couple of show commands to verify our NTP configuration. Let's get started here on router R2. And I'm going to go into global configuration mode, and I'm going to say NTP master. And here's where I can give my stratum value. Notice we're not even allowed to configure ourselves with a stratum value of a 0. That's reserved for those internet-based cesium clock time sources. I'm going to say that I have a stratum value of a 4. Let's set up NTP authentication. I'll say NTP authenticate, or authentication key rather. I'll say key number 1, a locally significant value. We're going to use MD5 hashing, our only option by the way. And I'm going to say capital C, 1, $C, and 0 as my authentication key. I'm going to say that key is trusted. The NTP trusted key is 1. And finally, I want to enforce that we are going to be doing NTP authentication. That's our configuration. That's our configuration on what we're going to refer to as our NTP server. Now let's go over to our client, our NTP client, router R1 on screen, and let's go into global configuration mode and let's point to that server. We're using router R2 as the server. I'm going to point to its loopback IP address. I'll say NTP server, and it's going to be 2.2.2.2, and I'll need to say NTP authentication key. Let's give a matching key. Again, the locally significant number here that I'm giving of a 1, that does not have to match on the server. That's just significant to this router's configuration. But the password does have to match. We're using MD5 hashing, and the password is capital C, 1, $C, and a 0. Let's say that key is trusted, NTP trusted-key 1, and NTP authenticate. Now I happen to know that these routers were fairly close on their time before we did this, meaning that they shouldn't take very long to synchronize. Let's see what their status is right now. Let's do a show NTP status. And right now it says we're unsynchronized. All right, not a big problem. Let's check. Do I have connectivity to my NTP server? That's one thing that could go wrong. Yes, I've got connectivity. We're not synchronized yet. Not a big problem. Like I said, it could take 15 minutes sometimes for this to synchronize. I don't think it'll take us quite that long. Let me try again. Nope, still not synchronized. Let's go a step further though. I've said I want to learn time from this clock, but I want to be local to my time zone. We need to go in and set our clock to be in our time zone. Let's go back into global configuration mode, and I'm going to say clock time zone, and I'll say EST for Eastern Standard Time, and I'm 5 hours behind UTC or Greenwich Mean Time. We'll say EST -5. Also, where I live, we do observe daylight savings time. And we spring forward in March and we fall back in November. I don't remember the exact dates that we do that, but I don't have to. If I'm running current Cisco iOS, I can just say that yes, we're doing that summertime time zone adjustment, and it's recurring. Here's how I could set that up. I could say clock, summertime. What's it called during the summer? Well, it's called EDT, Eastern Daylight Time, and I could specify a date and a time, and I could be really specific about when this occurs, or I could just say recurring. Like I said, current Cisco iOS, it is going to use what's currently valid in North America as far as springing forward and falling back. It looks like we are now synchronized. Excellent news. Clock is synchronized. Now, notice, my stratum value is a 5. Why is it a 5? Because I learned from a router that had a stratum value of a 4. It was incremented. Here is the IP address of my NTP server that I learned that from. That's a basic configuration of both an NTP server and an NTP client.